Hello everyone, in this video we'll study geometric sequence. First we'll start with definition. The sequence Tn where Tn not equal 0 is called a geometric sequence if Tn plus 1 over Tn equals a constant for each n belongs to Z positive, and the constant is called the common ratio of the sequence and it is denoted by the symbol R. Okay, here Z equals the positive integers 1, 2, 3, and so on. Example, show which of the following sequence Tn in the geometric is a geometric sequence. Then find the common ratio of each. Here we'll start with letter A. We have Tn equals 2 multiply 3 power n. So Tn plus 1 equals 2 multiply 3 power n plus 1. Again, we here have Tn equals 2 power 3 multiply 3 power n. So here we have n and the power is n. N here is the order of the term. But here we have Tn plus 1. So we can say that n plus 1 is the order of this term. So we write it's equal 2 multiply 3 power n plus 1. According to the definition, we have Tn plus 1 divide Tn equals 2 multiply 3 power n plus 1 over 2 multiply 3 power n. This sequence, it will be a geometric sequence if the result here is a constant. So we must simplify this fraction, dividing up and down by 2 here. So the result equals 3 power n plus 1 minus n, which equal, we have 3, it is the base, n minus n equals 0. So we have 3 power 1, which equal 3. And 3 is a constant. It doesn't contain any variable. So the sequence Tn equals 2 multiply 3 power n is a geometric sequence. Now we'll try letter B. We have Tn equals 4 n power 2. So Tn plus 1, it is the next term, equals 4 multiply n plus 1 all power 2. And now we try Tn plus 1 over Tn and we check the result. Tn plus 1 equals 4 multiply n plus 1 all power 2 over 4 n power 2. Dividing up and down by 4, we get n plus 1 power 2 over n square. And this result is not constant. So this sequence is not geometric sequence. The sequence is not geometric sequence, and it is not have any common ratio. What about the sequence in 3? Here we have, in this sequence, we have Tn here Tn equals 1 over 4 multiply Tn minus 1, and n is greater than 1. Okay, so we can check this. Tn divide Tn minus 1 equals 1 over 4. Note that Tn over Tn minus 1 express two consecutive terms. As Tn minus 1, it is the term before Tn. In other words, Tn is the term after Tn minus 1. Okay, and the result here is a constant. So the sequence is geometric and its common ratio R equals 1 over 4. Here we have another question. Tell which of the following sequence is a geometric sequence, then find its common ratio in case it is a geometric sequence. Okay, A here we have Tn equals 3, 6, 12, 24, 48, and 96. Now we can make another test for this, dividing every two consecutive terms. So here we have T1 equals 3. Here we have T1 equals 3, T2, T3, T4, and so on. Now dividing T2 over T1. T2 divide T1. What is the result? It will be 6 over 3, which equal to. Also, when you divide T3 over T2, what you get? 12 over 6, which equal to. Also, T4 divide T3 equals, what is the value of T4? It is 24. Divide T3, which equal 12, and the result also equals 2. So this sequence is a geometric sequence because also if you divide 96 divide 48, you will get 2. 48 divide 24 equals 2. So the sequence here Tn is a geometric sequence, and its common ratio R equals 2. Let's try this geometric sequence. Tn equals 1 over, this sequence Tn equals 1 over 243, and T2 equals 1 over 81, and T3 equals 1 over 27, and so on. I'll try it by the same way. Okay, how? First, let us delete this. Okay, now we solve B here. We have Tn. Okay, I'll start from T1. We have T1 equals 1 over 243. T2 equals 1 over 81. Okay, let us divide T2 divide T1 and we observe the result. Here we have 1 over 81 divide 1 over 243. Using calculator, what we get? 1 over 81 divide 1 over 243. The result equals 3. Okay, here we have T3. I will divide it by T2. So T3 divide T equals, what is the value of T3? It is 1 over 27 divide 1 over 81. Also it is equal 3. By trying 1 over 9 divide 1 over 27, you will get 3. Also 1 over 3 divide 1 over 9 also equals 3. So the sequence, this sequence is geometric sequence, and the common ratio are equals 3. Here in this sequence we have Tn equals 5 multiply 2 power n. So we will try Tn over T, no, so we'll try Tn plus 1 over Tn. Tn plus 1, it is 5 multiply 2 power n plus 1 over Tn, which equal 5 multiply 2 power n. Dividing up and down by 5, we get 2 power n plus 1 over 2n, and the result equals 2 power n plus 1 minus n. In division we subtract powers. N minus n equals 0. So the result here, it is 2 power 1, which equal 2. And 2 is a constant. So the sequence here is geometric sequence, and this common ratio R equals 2. Now we have letter D. Tn is a sequence 3 equals 3 n plus 1 power 2. So Tn equals 3 multiply n plus 1 all power 2. Now what is the value of Tn plus 1? Tn plus 1 equals 3 multiply, substituting n plus 1 plus 1 all power 2, which equal 3 multiply n plus 2 all power 2. Dividing Tn plus 1 over Tn, we get 3 multiply n plus 2 all power 2 over 3 multiply n plus 1 all power 2. So dividing up and down by 3, we get n plus 2 all power 2 over n plus 1 all power 2. And if you expand these two brackets, what you get? N square plus 4n plus 2 over n square plus 2n plus 1. Here we have 4. Okay, and this fraction is not constant, it is variable because it is contain n. Okay, it's contain n, so it is not constant. We can write it is not constant. So the sequence Tn equals 3 multiply n plus 1 all power 2, not geometric sequence. Graphical representation of a geometric sequence. Example 2. Find the next 4 terms of the geometric sequence 8, 4, 2, and so on. Then represent the first 7 terms graphically. First, in the solution, we will deduce the common ratio. How? Dividing T2 over T1. T2 divide T1 equals 4 divide 8, which equal half. Also 2 divide 4 equals half. Then the common ratio R equals half. Now we will write the first 7 terms. Here we have 8, 4, 2. Now multiplying by half, you will get 1. Multiplying by half, you will get half. Multiplying by half again, you will get 1 over 4 and 1 over 8. Now we want to represent these 7 terms graphically. So we have the graph. Here we have in the horizontal axis we have n, and n. The vertical axis we have Tn. N belongs to Z positive, but we will start from 0. Here we have 0, 1, 2, 3, 4, 5, 6, 7, 8. And we have Tn. Okay, and we write 1, 2, 3, 4, 5, 6, 7, 8, and so on. When n equals 1, we have T1. It is equal 8. When n equals 2, Tn, it is the second term, equals 4. When n equals 3, we have 2. And so on. When n equals 4, we have 1. 4 and 1. This point is 4 and 1. Okay, n. 4 it is n, 1 it is Tn. Here is the relation between n and Tn. Okay, 5 and half, 6 and 1 over 4, 7 and 1 over 8. And this is the graphical representation of the geometric sequence. Finding the nth term of a geometric sequence. From definition 1, the nth term of the geometric sequence Tn, whose first term is A, and the common ratio is R, can be deduced as follows. Here we have T1 equals A, and T2 equals AR, and T3 equals AR power 2, and T4 equals AR power 3. Okay. Here, notice the relation between the order of the term and the power. The power less than the order by 1. So when you want to write T20, what you get? We get A power multiply R power 20 minus 1, which equal AR power 19. So by continuing this step, this pattern, we find that the nth term of the sequence, the geometric sequence, is Tn equals AR power n minus 1. Okay, Tn equals AR power n minus 1. And now let us go to the examples. Example 3, in the geometric sequence 2, 4, 8, and so on, find first the fifth term. Second, the order of the term whose value is 512. Solution. Here we have the geometric sequence equals 2, 4, and 8, and so on. Okay. Now A equals 2 and R equals 4 divide 2, which equal 2. And we must write Tn. Tn equals AR power n minus 1. Okay, you must memorize this form for the general term. Okay. Now, we wanted to find the fifth term. So T5, according to the definition, equals AR power 4. 5 minus 1 equals 4, which equal A. What is the value of A? It's 2. Multiply R, it's 2 again, power 4, equals 2 multiply 2 power 4 is 16, and the result equals 32. Okay, now second here, the order of the term whose value is 512. Again, we write Tn. Tn equals A R power n minus 1. Okay, here we have Tn equals 512, which equal A. What is the value of A? A, it is 2. Multiply R. Also here we have R equals 2 power n minus 1. So 2 power n minus 1 equals 512 divide 2. 512 divide 2 equals 512 divide 2 equals 256. 256. Okay, so we have 2 power n minus 1 equals 256. 2 power 8 equals 256. So we can write 2 power n minus 1 equals 2 power 8. Again, we have 256. Using calculator, you get 2 power 8. Since the base equals the base, you can write n minus 1 equals 8. And from that, you can deduce that n equals 8 plus 1, which equal 9. So the term whose value is 512 is the ninth term. Okay, let us take another question. Prove that the sequence Tn, where Tn equals 2 multiplied 3 power n minus 5, Tn equals 2 multiplied 3 power n minus 5 is a geometric sequence. Then find its seventh term. First, we want to prove that this sequence is a geometric sequence. How? First, we write Tn plus 1, which equal to multiply 3 power, instead of n, we write n plus 1 minus 5. So Tn plus 1 over Tn equals, here we have 2 multiply 3 power n plus 1 minus 5 over 2 multiply 3 power n minus 5. and we will simplify this fraction. It is equal. First, you can divide up and down by 2. So we have 3 power n plus 1 minus 5, it is n minus 4 over 3 power n minus 5 equals here 3 power n minus 4 minus n minus 5, which equal 3 power n minus 4, and to expand this bracket it will be negative n minus multiply minus, it is positive 5, and now we have n minus n equals 0, so it is equal 3 power 1, which equal 3. Negative 4 plus 5 equals 1. Okay, we have Tn plus 1 over Tn equal a constant number, it's 3. So the sequence Tn is a geometric sequence, and its common ratio R equals 3. Okay, now find its 7th term. Directly here, you can find the 7th term substituting n equals 7. So we write T7 equals 2 multiply 3 power 7 minus 5, which equal 2 multiply 3 power 2. Again equals 2 multiply 9, which equal 18. Okay, add 3 power 2 equals 9. Also you can find the T8. T8 equals 2 multiply 3 power 8 minus 5, which equal 2 multiply 3 power 3. 8 minus 5 equals 3, equals 2 multiply 27, okay, which equal 54. Okay, 2 multiply 27 equals 54. Let us check the common ratio. T8 over T7 equals 54 over 18. 54 over 18, divide 18 equals 3. So the common ratio equals 3, and we got the right solution.